Okay, you guys, we're reviewing. We're gonna review today, tomorrow, Monday. Test is Tuesday, Wednesday. If you do the green pack and understand it, this should be a piece of cake. Question? Pardon? No, I'm using it with my seating chart, which is wrong. Did your whole row miss it? Or just you? No. Okay, you guys, listen up. Girls, the test is Tuesday, Wednesday. Today we're going to go through the gold sheet, pretty much most of it, and we'll get answers put up on Schoology, and then we'll do some of the things off the green one, and you'll have some time to work on the green one, tomorrow. And then we have a little activity on Monday. And really, there's only two concepts that have been in this chapter, limits and continuity. That's it. Now, there were two kinds of limits. Limit as x approached a number, and then we had the limits as x goes to infinity or negative infinity. And we'll do a number of those today. They were over there. You should have them. I might be out by now. If you took one and you didn't need it, please return it.
Is it this one?
Mm-mm.
Do I need this one? Because I don't have this one either.
Yeah, we did that one a few days ago, yeah.
Oh, was it green?
No. Let's go. Did we ever do that one? Yeah, that was infinite limits. Yeah, you did.
I feel like I printed that one out from school with you.
Maybe. Okay, you guys, look at your stuff. There's another gold one here. No.
That's the same as that one.
You guys, I gave this out all together, so everybody should have this sheet. Okay? So if you don't, if you have it already, don't take another one. So look through your stuff, because we have people now that don't have it for some reason. It looks like, I'll go to the first page. It looks like that. Chapter 2 review. It happens to be orange. Single sheet. Look at that. Yeah, you do have it. A lot of people said they didn't, but you have to have had it. None of this, because I had extras I flipped over here. You can, if you don't have one, you can just take a piece of paper and write it down. It is up on Schoology. That's right. And we're going to start with the last problem on the back side. So look at your neighbors, because it's impossible to see that. We are going to do that. That's exactly what we're going to do. We're starting with this one. Okay, let's read this. This is an AP question. Okay, guys? This is a free response question. It's only part A. And when you take the exam and you look at free response questions, each question will cover all parts of the year. You're not going to just have a free response question that covers just chapter 2. It's not going to work that way. So it's going to be mixed up with things. And this says I have two functions, f and g. They're differentiable. We don't know what that means. For all real numbers, g is strictly increasing, which means it's just getting bigger. That's all it says. The table above gives values of the function and the first derivatives. We don't know what derivatives are either. So your question is, well, what's f prime and g prime? Those are derivatives. But I don't know what they are yet, so I'm not going to pay any attention to them. I'm going to do what I can do. That's why only part A is there. And it says the function h is given by, and I'm going to write it up here so you can see it. H of x is equal to f of g of x minus 6. Part A says, explain why there must be a value r such that r is between 1 and 3, such that h of r is equal to negative 5. Well, I think the r throws you off right away. It kind of threw me off too. In other words, r is just an x value. So why don't we say this? Explain why there must be an x value so that x is between 1 and 3, such that h of this x value is equal to negative 5. I don't know what the x value is. I think that helps make the problem a little bit easier to understand. So they're going to tell you that h of x is equal to -5 someplace. How could I show it has to be -5? We did this yesterday. It's a theorem. Intermediate value theorem. So if somewhere, if you think of these as temperatures, the temperature at some time is 5 below 0. Well, if it started at 10 below and went to 10 above, didn't have to go through -5 sometime? Now, I don't know when. That might bother you, but I don't care. I just want to show that it had to be -5. So it's the intermediate value theorem. So, and there are no tricks on these. You're just going to evaluate h at 1 and a 3. And guess what? You'll get a number less than -5, and you'll get a number greater than -5. So let's do that. They're having you practice with tables. They love tables. So let's find h of 1. Now, last class said they didn't know how to do this. So what's h of 1? You're going to put 1 in right there for x. So it's f of g of 1. Does it help to call that x instead of r? Helps me. I'll admit it. Okay, now you're going to read in the table g, and that's this one. The other one is f, and we're going to ignore the f primes. But this is a real problem. So if you're on the exam, you have to know when to use which column. Is it easy to get them mixed up? Yes, so you want to show your work. Don't just put numbers in. Write that out. It's f of g of 1. Now, what's g of 1? 2. Okay, Brian? You know what you're doing over here? It's f of 2 minus 6. What's f of 2? Because it was g of 1. We start from the inside. G of 1 is this column is 1, and I go over here to the 2. Now, it's f of 2. Some of you are going to just want to write down the answers. Don't do that, because on the free response, I don't know how this was graded, but you might have gotten a point for making this first line right there. And then if you read it wrong, then you're going to lose the other point, but that's the way that goes. What's f of 2? 9. So 9 minus 6. So h of 1 is equal to 3. That's greater than -5. So I need to find an h value that's smaller than -5. Just use the endpoints of the interval, because they've designed it for that to work. You're not going to have to use anything in between or take some guesses. Question? Ask. I took f of 2, so let's go back up into my chart, and f of 2 is right here. Okay? You got to ask those questions, because when you get lost, you get frustrated. I know. I've been in math classes. I know you don't believe that, but I've been in math classes where I'm going, what is going on? It's true. So it's not 4. Where's the endpoint of my interval? H of 3. So it's f of g of 3 minus 6. I'm just using the endpoints of my interval. They're not going to trick you. If they give you an interval and you recognize this intermediate value theorem, if they had said temperatures, they would have, if they had said, show that at some time the temperature was 5 degrees below 0, then you would be thinking, oh, I just have to find a temperature less than that, a temperature greater than that. Sometimes they put them in context, sometimes they don't. I like it better, actually, when they're in context, unless they have too many words. That happens, too. Okay, can you find g of 3? Okay, so g of 3 is 4. Everybody see that? Okay. And if you don't, you got to let me know. So this is h of 3 equals f of 4 minus 6. So what's f of 4? Everybody see why it's -1? It's right here. So this is equal to -1 minus 6, or -7. I'm going to write out my response. Since h of 3 equals -7 and h of 1 is equal to 3, by the intermediate value, and I would say and h is continuous. How do I know it's continuous? Because I can't use the intermediate value theorem unless it's continuous. Well, you don't know why it's continuous. It is because of this word differentiable, which we're going to run into in the next chapter. If you have a function that's differentiable, it's also going to be continuous. So right now you just have to trust me. Okay, since h of 3 is negative 7 and h of 1 is 3, then h must hit all values between negative 7 and 3. Does that make sense? They specifically asked for negative 5, but they could have said, is h ever equal to 0? Yeah. If they had asked, is h ever equal to 4, you'd say, I don't know. And they might do that, by the way. They have done things like that, where you can't. You say, I don't have enough information. And you might have to quote the intermediate value theorem saying 4 is outside of my interval. Because I know the one output is negative 7, the other one's 3. All I know is that I'll achieve all numbers in between there. So since that's negative 7 and that's 3, h is continuous, and h is continuous, then h is going to be between 3 and negative 7. And you know the symbol for therefore? I don't know if I did in that class. Therefore, h of r or h of x, they won't mind if you change it to x, is equal to negative 5 by what theorem? Intermediate value theorem. So there's your example of the AP question that has intermediate value theorem on it. And there's others. And now, if it's not on the free response, it will be in the multiple choice. That's a guarantee. There's like 6 theorems. This is one of the ones you have to know. I have always seen a table, but I don't get to see all the multiple choice questions. So you might not see a table on the free response, but you will see somewhere. They love the tables. Okay, Noah? You get 2 Noahs. Okay. Are we done with that? Yep. More? The next one we're going to do, if you want to look at it, is the very first one at the top of the page, number 9. Okay, ready? Okay. What are all the horizontal asymptotes of the graph of y equals? This is 2008, number 19, multiple choice. This is the one they threw out of the exam. It's the only one they've ever done that with. So I don't know why they did that. Why not just curve the exam a little bit more? But they did. The first answer was I don't know what C was. Oops, that's supposed to be y equal to. Because I know the problem. And I don't remember what E was. Let's do the problem. Now, when you look for horizontal asymptotes, what is that asking you? Find what kind of limit. The only things we've done are limit and continuity, right? The limit as what? X goes to what? Infinity. And I just use my intuition, which works most of the time, not all the time. And so maybe I'll put some numbers in. Why don't we say x is 100? Because I want to figure out what's happening. Because this is not in our little rules. These are not polynomials. These are exponentials. They have different rules. So I'm just going to think my way through the problem. So 5 plus 2 to the 100th power over 1 minus 2 to the 100th power. Do you think the 5 and 1 amount to anything? No. So it really looks like a positive 2 to the 100th divided by negative 2 to the 100th, which reduces to what? Negative 1. Well, my guess is what happened on the exam, and that's probably why they threw it out. And they can do this to you. The first answer is y equal to negative 1. It's one of the answers. There's more than one answer here. But students saw that and said, oh, that's the answer, and went on. Always read through all the choices. They do like to do that. They're test-taking strategies here. There is another answer. But students saw their first answer and said, that's the answer, and went on. And so there were very few students that got this right. So we are going to do the other one. What's the other problem we have to do? The limit as x goes to what? Negative infinity. This one's tricky because that's not x squared. It's 2 to the x. So that little rule about, the exponents being the same doesn't apply. It's not exponential. So let's try some numbers. When you don't know, try some numbers. So we'll try x equal to negative 100. So it's 5 plus 2 to the negative 100 over 1 minus 2 to the negative 100. And then you have to think. Don't cancel the 2's. I'm not sure if you want to cancel and what you want to do with it. But I don't like negative exponents, do you? So let's write it as positive. So this is 4 plus what? That's 4. 5 plus 1 over 2 to the 100. Now it's going to become clearer, I think. Then this is 1 minus 1 over 2 to the 100. What are they going to? They're not canceling. What are these guys going to? Because if this was 3 to the 100, I would still get the same response. They go to 0, don't they? If I had 10 to the 100, and that's 2 to the 100, then what do I do? Because 1 divided by 2 to a huge power, I'm going to give I have $1 on me, and I'm going to give it to everybody in the school and divide it up equally. How much will everybody get? 0. Because that's what that says. You take 1 and divide it among $1 and divide it 2 to the 100th power people. I don't even know how big that is. It's huge. I did the negative. This is because I have to do negative infinity and positive. So I have to check both ways. A horizontal asymptote is not always the same over there and over there. You want to think it is for polynomials, but this isn't the polynomial. I don't know. They threw it out. Because very few people got it right. They just threw it out. Didn't count it. I've never seen that happen before. Why didn't they just curve it? I don't know. But I think they felt that too many people looked at the first answer, didn't read all the answers. But honestly, some people might have looked at that and still gotten this part wrong and not missed it. So the correct answer is D. And we'll look at these. And I have stats on these, all these multiple choice problems. They're statistics. So when you start working those problems, and we're not ready for it yet, but when you do, we'll see how many people got it right, what percentage got it right. And when you get it right, you're going to say, hey, this is good. I got it right. But only 40% got it right. So it's good. Oh, we're going to do all these, as many as we can. Yeah, so let's look at 10. Because there's really 2 kinds of limits. As x goes to infinity or negative infinity. These are just limits. Okay? Or as x goes to a number. Now, when I want to do 10, if I'm looking for end behavior here, now these are polynomials. Now I can use that little rule about the exponents, but you know what? It's just easier to do the problem. I want the biggest exponent. That's the degree. What's the highest degree here? What happens when you multiply 2x times minus x? Minus 2x squared. I know that I have x's and other things, but they just don't matter. Now when x gets really big. And what about the denominator? X squared. And what will happen to the x squared? I'm not going to memorize that. It's too easy. They just cancel. So what's the limiting value here? Negative 2. That would be y equal to negative 2 if they asked you for the equation. Yeah. Because x goes to infinity is end behavior. This is at a point. At points, now what can happen? It could be clearly defined. You can find a limit. You could have a vertical asymptote, or you can have a hole. That's it.
How did you know what a horizontal asymptote would give you? Like, how did you know to go about that?
Because I want to take the limit as x goes to infinity. On 9, again, it's as the limit as x goes to infinity. So horizontal asymptotes are always looking at limits as x gets really big or really small. Okay, so if you want to organize your thoughts, how do you study? Take notes on your notes. That's how I used to study. It could be undefined. It could be infinity. In this case, it's not. It could be. What if I had the limit as x goes to infinity of x squared over x? Not 0, but you could reduce that. That's equal to just x, and x is going to get really large. Let's do 11. What's the first thing you always do? Before you factor, substitute in. Okay. You get 0 over 0. So now what do? We factor it, right? When there are polynomials, you get 0 over 0. You're going to see some factors there. What comes out of this one? Let's always do greatest common factor first. X squared, and I'm left with 5x squared plus 8. Did I do that right? Take out an x squared here. I'm left with 3x squared minus 16. Where's the whole? What factors that cancel that's going to be the whole. So this is the whole. Remember, do we care what happens at 0? Nope, we don't care at all. Now, since we're going to cancel those out, because we're not at 0, I can do that. Now that's dividing. You're left with a 1. Now what are you going to do with the zeros? Substitute them in, and you get what? 8 over negative 16, which is negative 1/2. If it's free response, leave it alone. Leave it negative 8 over 16. Is that okay in the back? Don't simplify. If you simplify it wrong, it's wrong.
If you simplify it right, it's
No, it's fine. But a lot of students do it wrong. I'll share with you last year's problem when it fits.
right now.
Now, what is this? X is going to infinity. No, you just find the limit. This is end behavior. What's the biggest exponent on number 12? I want the highest degree. Okay, so it's this guy, right? So it looks like 5x to the 4th over 3x to the 4th. Oh, that's kind of nice. What's going to happen to the x to the 4th? That's all. Well, if they're polynomials, remember my first problem with exponentials. You might have to put some numbers in to figure it out. But that's okay. I think the back's all done, right?
Yep.
Now we're going to do the front. When you're on the test, just imagine I'm sitting next to you. And then you'll say, I don't know what to do with this. And then you'll in your head, think of me saying, well, what would you do with this? Put in some big numbers, maybe. See what happens. Okay, ready? Okay. First thing, what's the first thing you do?
Plug in 5.
Substitute in 5, and what do you get?
0.
I get 0 over 0. The request was for, we're going to do the hard ones first and then go back. Is that okay? Now, that's a complex fraction, and I know you guys don't like fractions. We did something like that on the quiz. Now, do you expect to see something this hard on the test? Yes. Okay. So, here's what you want to do. Don't skip. You want to get rid of the denominators. And in my algebra class, first hour, we talk about getting common denominators. And I said, you know what always works? Just multiply them all together. You might not get the smallest one, but who cares? We'll deal with that later. We just want to get rid of them. So I have this denominator, this one, and a 1. So I'm going to, now you guys didn't do it this way maybe last year, but I'm going to clear them out. Because why does this work? What number am I multiplying by? 1. If I take 2/3 and I square it, have I changed the problem? Are these equal? 2/3 and 4/9, they're not equal. So squaring numerator and denominator isn't the same thing. I'm multiplying by 1. You probably got common denominators and did reciprocals and stuff like that. I hope not. You should have done it this way. Okay. And so now we're just going to distribute. I'm going to take this and distribute times the 6 and times the -5. Be careful. I have to print out my little hints, and one thing is the case of the invisible parentheses. You need the parentheses there. Don't skip steps, because that's when you get it wrong. I've been doing this type of math for over 30 years, and I don't skip the steps, because I want it right. When you take off in a plane, what do? They have a checklist. They don't ever skip any checks. Well, I hope they don't. So we're just going to multiply that out. What's going to happen to the x plus 1s with the x plus 1s? So we were left with 6 times x minus 5 times, and the x's are going to cancel. Do I need this parentheses? Yes. Those of you who like to do it in your head, you probably get it wrong 50% of the time. Not a good thing. Okay, so x minus 5, and then this is x, and this is x plus 1. And that's why the pilots have a checklist that they have to go through and check it off. They've done it hundreds of times. It doesn't matter. They go through that checklist because they don't want to forget something. Now, some of you want to go and cancel the x plus 1s. You can't do that. Let me give you an example. What if I took 2 times 3 over 4 versus 2 plus 3 over 4? See, when you don't know what to do, you go back to numbers because you know what this is. That's 6/4, and this is 5/4. Can you cancel the 2 and the 4 here? No. Because when you cancel, you're dividing by 2. 2 goes into 2 once, 2 goes into 4 twice. You really should put these numbers down because if I try to do this, 2 goes into 2 once, goes into 4 twice, but I haven't done that to everybody in the problem. That's a plus, not a times. So I'd have to do that, which is just as ugly. So why do that? So I can't cancel the x plus 1s. But what I can do is I can go ahead and multiply that out and then combine similar terms. You always want to simplify your numerator until you can't get it any more simple. Then you factor. So it's the limit as x goes to 5. That's 6x. And what's this going to give me? Minus 5x minus 5. And again, some people still want to cancel. You can't. And I'm not going to multiply that denominator out because the only way you can reduce fractions is to have factors. Things you add together are called add-ins. It has to be a multiplication problem to be able to cancel anything. Can you simplify that? And remember, you had 0 over 0, so I know I'm going to have some common factors. So that's x minus 5, right? Over x minus 5 x, x plus 1. This is where we're learning our algebra, isn't it? This is not calculus. This is algebra. And this is times what? 1. Now I can reduce it. I'll divide by x minus 5. It goes in once. And x minus 5 goes in once. So what's the answer going to be?
Wait, why can you cancel that?
Because this is times. See, I can do the 2 times 3 over 4. 2 goes into 2 once. It's not distributive, it's associative property. If you want to write it out as factors, numbers multiplied together, that helps. That's what we're doing.
Wait, and then so is it 1 over?
Yes. So it's the limit as x goes to 5. Remember, x's are just numbers. They're just numbers. So this number isn't x, it's x minus 5. The number here is the difference between whatever that variable is and 5. It's just some number. And so I'm left with 1 over x times x plus 1. So if I substitute in 5, I get 1 over 5 times 6, or 1/30. If I take this polynomial, x squared plus x plus 1, does that factor? Does that factor? No. That's prime, right? If you can't factor something, you say it's prime. Let's let x equal 1. If x is equal to 1, that's 1 plus 1 plus 1. Guess what? That's prime. If I put x equal to 2 in there, I get 2 squared plus 2 plus 1. What's that number? That's 7. Guess what? That's prime. You can't factor that. So when I say this is prime, that's prime for any number you put in there. You will always get a prime number. You can put 100 in there, and you'll get a prime number. It's kind of interesting of it. You never thought of it that way before. Yeah, so this is a class where you're going to learn your algebra. Okay, the only thing that was calculus here, well, the 0 over 0, and then knowing I want to change the form of that and get in the answer, substituting the calculus. So the next hard problem is number 6. We're going to do 7. We can do 7 first. What do you always do first? It's too easy, isn't it? Substitute. So it's 2 times a negative 3, and it's minus 3 minus 3. So it's negative 6 over negative 6, or 1. You always substitute first. The infinity is the only one you're looking at what's the end behavior. Otherwise, there are always going to be numbers. So let's do number 6. I'm going to do it on a new sheet, though, because it's too hard to see. Sometimes it doesn't work very well. And there it is. Okay. You guys see that in the back? I could rewrite it. It's the limit. At least I have it in front of me to rewrite it. Square root of x minus 2 over x minus 4. Now, these are just plain limits. We're not doing any continuity. Just finding a limit. And when you substitute in 4, what do you get? Okay. This is not a polynomial. The denominator can be factored. Some people will factor it because they see that. And I don't always see that. So what I'm going to do is a math trick. It's just a trick. I want to change the form. Some of you want to square the numerator and denominator. That won't do you any good. And it's really not, and yet you're changing the value besides. So that's not a good plan. So, because it's not correct. But what I can do is I can multiply by a form of 1. And it's just a trick. How would I get rid of the radicals? Square root of x plus 2 over, I want it to be 1, square root of x plus 2. Rationalizing the denominator is not a valuable skill anymore. Because why did we ever rationalize the denominator? didn't have a calculator. I had a slide rule. You just said to slide it. You could not divide by an irrational number on a slide rule. That's why we rationalize the denominators. Well, we don't have to do that anymore. However, I want to do it here to change the form. That's it. I just want to change the form. It's a trick. Think of it as a trick. Math magic. Nothing magical about it. I'm just changing it so it looks different. It still has the same value. Okay, so let's go ahead and multiply this out. What's that going to give you? Gives you x. Now, my trick ended up getting rid of the radicals in this top, in the numerator, right? You guys see that? It's minus 2 square root of x plus 2 square root of x goes away. And then the last ones are minus 4. But that's really times 1. FOIL. I multiplied the first ones. Square root of x times square root of x is x. That gives me minus 2 square root of x. The outer one gives me plus 2 square root of x, which is why we practiced with radicals earlier. But if you have a minus 2 and a plus 2, you get nothing, right? And then to do the last ones, negative 2 times positive 2 is a minus 4. Okay, and now we are not going to distribute that. We are going to leave that factored. And remember, anytime you got 0 over 0, you have a whole. And there's the whole at 4. But do we care about what happens at 4? No. Never, not on a limit. Continuity, I do. You gotta get those two straight. And I'll put a discussion link. You guys can discuss the difference between limits and continuity. I'll put that up on Schoology. Okay? I'm not going to require it. I'm just going to put it up there. Those of you who want to participate can. Okay, go ahead and substitute 4 in. What is this? If I were free response, I would leave it like that.
Wait, why? No, it's not.
Because if I do it wrong, then I lose my point. Now, you know, you're going to see one of these on the test? Yes, you are. You're going to see fractions. If you do this practice test, you will be in great shape if you understand it. Don't memorize it, but understand it. So on this page right here, there's one with a radical in it. Looks similar. It's in the letter C. And there's one with a fraction on it, letter E. Okay, so you've got more to practice with. How do you study for a test? You cover up your answers, and you do the problems again. Because you won't, I don't think you'll memorize them. Try not to memorize them. Okay. Now, we did almost all the tough ones. The other tough one was, this is 1/4, is number 5. That one's a tough one, right? Should we do that one? I think I have it here. There it is. Number 5. This is one of those piecewise graphs. So, because of the absolute value, if I didn't have the absolute value, life would be really easy. But it's unfortunately not. What happens when I put in -1? I get 1 plus 4 minus 5 over 0. Okay, I got troubles. So what I'm going to do is rewrite this limit, not limit, this function as a piecewise graph. We'll do the easy part first. This is x squared minus 4x minus 5. Now, if x, I don't have to have the absolute value symbol if x is greater than what number? Close, not 0, -1. Because this is just the translation of your v. The v is now at -1, not 0. Because y equals the absolute value of x. Looks like this. And y equals the absolute value of x plus 1. Looks like this. Remember your transformations? So I'm going to break it into 2 pieces. Here's -1. Okay? So I can just use that side. Well, that's just x plus 1. What if x is less than -1? Then I get x squared minus 4x minus 5 over, what's the equation of this side of the graph? Not x plus 1 anymore. It's the minus of that, isn't it? By the way, why do I get good at this?
Practice.
Because it's practice. I mean, I do it twice a day, every day. I better get good at it, and I've been doing this since 1991. Still make mistakes. Yes, yeah. I do, because this is not a nice function. It's a piecewise. If you get polynomials, it's great, but absolute value is a piecewise function.
So first you get 0 over 0, and then you have to like split it up.
Right, if I didn't have the absolute value, then life would be easy.
Wait, so can how do you solve that?
No, okay, now we're now going to take the limit.
How?
Well, what's true for a limit to exist?
It's being equal.
The limit from the left has to equal the limit from the right. Let's do the limit from the right. The limit as x approaches 1, from the right side, I can use this formula right here. Can we factor that? Remember, if I got 0 over 0, I have to see the x plus 1 in that numerator. It's my little trick. What's this value going to be? It's a negative 1, sorry. Minus 1 minus 5 is negative 6. What if I go from the left? I'll use the other formula. So it's the limit as x approaches negative 1 from the left. I get all confused with those signs. So you have to slow down and read it. Same factoring, because that didn't change, but the denominator is minus this. It's going to happen to the x plus 1s. They're going to go, and you're going to put in a negative 1, but you have a negative in the denominator. So it's negative 1 minus 5 over a negative 1. That's equal to what? Positive 6. Are these equal? Negative 6 and positive 6? No.
So, but do we have to show that top part to show that you're doing both sides?
No, you have to at least do this. I did that to help you see that.
Okay, but if you stop.
No, you can go straight to that. So you say it doesn't exist because the limit from the left doesn't equal the limit from the right.
So you just write the end.
Right.
If I wrote that on my exam, would
You'd have to have the work.
if I okay, and then I just wrote the ending, would they know something?
That's accepted. Okay. There are some easier ones. There's a sine one there. Let's do the sine one next. And then we're going to do the first one on the green sheet. I hope we make it time-wise. Okay. Can I pull this 3 out of this one? Oh, by the way, 2 is another problem. Can I pull that 3 out? Yeah, it's just a constant times the sine of x over x. Okay, so we have 2 limits that we have to know. And and by the way, read this carefully because I do this wrong every time because I'm not reading the problem. This is not x going to 0. This is x going to infinity. What's the biggest the sine will be? 1 divided by 10 to the 200th power. What's that going to? 0. Okay, you do have to know this limit as x goes to 0 of sine of x over x. That's equal to 1. There's another one. Limit as x goes to 0, and I don't think I did this with you. Cosine of x minus 1 over x, that goes to 0. And I could actually prove that if I wanted to.
Okay, so how do you solve this one? Wait, so the first one is at what?
It's 0
Why?
because I didn't read it carefully, and I caught myself this time. X is not 0. X is going to infinity. So it's 1. Biggest this will ever be is 1. 1 divided by a huge number is 0. I have $1. I'm going to divide it up and give everybody part of my dollar in the school. How much is everybody going to get? 0.
Wait.
They don't have coins small enough. Well, what's 3 times 0? What's 3 times 0? 0. Okay. As x goes to 0, not infinity. I know, I fall in that trap all the time. Yes. Well, yes, this particular problem is. Now, I'm going to take this one, and I don't think I'm going to get to the green sheet, the first problem, but that's okay. We'll do it tomorrow, first thing. And this is the cosine of x minus 1 over 1 times 1 over the tangent. But you got to be careful. It's cosine of x minus 1 over x. I don't have that x. Okay, first off, do you believe that these two things are the same? Yes, no? Okay, it's just properties of fractions. And this theorem says I have to have an x there. So you know what I'm going to do? I'm going to multiply by x here, and then x in the numerator. Can I pull that x through that operator? X is affecting that x. X is going to 0. It's not a constant. If I put an h here and an h there and that's x, yes, I could pull the h's out because they're just numbers. Okay, so this limit is 0. Now, 0 times any number is 0. If this is infinity or something, then I can't multiply those. So let's find this limit. I got to make sure it's just a number. I mean, I know it is. Now, do you remember the other trick that I said? Let's change tangent to sine of x over cosine of x, right? And the only place you have trouble is when you get zeros. No problem. This is 0, that's a problem. But what about this one? What's the cosine of 0? 1. Now, sine of 0 is always 0. If we can remember that, we'll never say the cosine is 0 of 0. Cosine of 0 is 0. Can't be. They're not the same. But this is 1. So I can evaluate a limit anytime I want. The only problems I have are when I get zeros. So if I don't get zeros, I can do that. So this now becomes this limit. And this is x over the sine of x. Some of you will instinctively know what that is, but it's the same as this limit. X approaches 0. It's 1 over sine of x over x. I can do that one. What's that one? 1 over 1, so it's 1. So I can reciprocal this one. Can I reciprocal that one? No, because it's 0 over 1. If I do the reciprocal, it's 1 over 0.
But then can you just always remember that x over tangent of x is equal to 1?
You can, except that on the free response, you have to justify your response. You have to convince me. Okay? You have to convince me. So when I do the sine of 5x over the sine of 2x, some of you know what the answer is. What's the answer? What's the answer to that one? It's 5 halves. But on the exam, if they ask you to do that and you just wrote down 5 halves, they will not give you any credit. So they call a bald answer. You have to convince the reader that you know how to do that. Some of you want to pull the 5 halves out. You can't do that. So it's the sine of 5x over the sine of 2x, right? And x is going to go to 0. I know the bell's going to ring shortly. Your job is to try to work through that green sheet tonight. No more than a half hour. We have time in class tomorrow. Okay? You can't pull the 5 and the 2 out of there. You have to do the little trick. Yes? I don't even remember what. It was 0. Okay. So, right, it's 0 because 0 times the number is 0. Do you want to take care of the 5x first? Remember, these have to match. So guess what we're going to do? We're going to put 5x here, and we're going to put 5x up here. This is where I can pull the 5 out. See if you can finish this one for tomorrow. And we'll see.